Fast responding RF detector. Hi, my name is Sasha from RF Power Group Texas Instruments, and today I'm going to talk about LMH2121, our fast responding RF detector. What is RF detector and where it sits in the system? Here you will see typical block diagram of a transmit system, and you see that 2121 sits right after power amplifier because you want to take a fraction of this signal and measure accurately the power that you are transmitting. Why is that important? Well, if you transmit more power than is needed, then it's waste. It's heat, the power that is just burned, and you are interfering with your neighbors. If you transmit less power, then you are reducing your data rates, and there is also a chance that your call will be dropped, and that's also something that you don't want. Now, what makes our device pretty much unique is there are three things. First, it offers large dynamic range, 40 dB, it offers very accurate temperature stability and low part-to-part spread, and it's fast responding detector. And all these three things I'm just going to show you in a sec. So, traditional approach is that here on the left side, people are detecting a power using Schottky diodes. And then if you see the input power range, you will see that in that range, characteristic is not unique. It's kind of square and then it's linear. So you need to use lookup table to compensate for this non-unique or non-linear characteristics, plus the temperature variations. Now, using our part, LMH2121, then in a whole input power range, like from -20 or -25 dB all the way to +15, our characteristic is pretty much linear and it has very good temperature stability. Now, I will going to show you a demo, the response, real response of this detector, where you see that in x-axis we are changing RF input power, and you see that this is the output voltage here, that our device starts reacting at -35, and at -30 it already starts reacting linearly, and then all the way up to 12 or 13 dBm, you'll see that our characteristic is pretty much linear. Here on the slide here, you can see also temperature characteristics, and for 900 MHz and for 1900 MHz, you will see that almost in 35 dB of dynamic range, it's really flat temperature characteristic within ±0.05 dB. So very good temperature characteristic. And here on this slide, you're actually seeing statistics of 50 devices, where you see that more than 35 dB of dynamic range, we are getting less than ±1 dB of temperature error, which is very good. Now, the next thing what we are going to show here today is fast responding feature of this device. And for that, I'll be back with you in just a second. For time domain measurements, we are moving to oscilloscope. The output of LMH2121 is shown as a blue line. Yellow line is showing input RF signal to our device, and that is LTE12RB. The fast responding feature of this device is shown in the form of following nicely the envelope of this LTE signal. Response, rise and fall time of this device is about 165 nanoseconds. For more information about LMH2121 and our full RF power detector portfolio, please visit ti.com/rfpower. Thank you very much.